for coming to the meetup here. It's really good to see a lot of you guys, especially in these kind of times of the whole COVID and everything. So it really means a lot that you're taking time out of your day with all the other things that are going on, work, life, etc. So thank you so much for joining us. Let's just start off with probably some updates. This is a joint venture meetup thing. So Jeff, do you want to start off with any updates or anything from the DevOps Chicago side? And you might have to unmute him, Adam. Yeah. Jeff Smith.
There we go. Am I back?
You're live.
Yeah. Hey everybody. Jeff Smith from the DevOps Chicago meetup. Not a huge update. Just want to let everyone know that currently DevOps Day Chicago is still currently being planned. Obviously that will be evaluated as the situation sort of unfolds with the pandemic, but the call for proposals is still open. It's going until Sunday, May 17th. So if you've got a talk that you wanted to submit and Ignite, or even one of the 30-minute sessions, feel free to go over to devopsdays.org and take a look at the Chicago DevOps Days and, submit your CFP and see what happens. But other than that, just kind of stay tuned to the meetup. There's also going to be updates posted on the DevOps Day Chicago website as we sort of navigate the pandemic and understand what the impact of the conference is going to be. But right now it's still scheduled for September 1st through 2nd at the UIC Forum on 725 West Roosevelt. So that's it. Thanks.
Cool. Did you want to also touch on your book club updates? I think you said there was.
Oh yeah, I forgot about the DevOps Days book club, the DevOps book club. So as part of this meetup, if you're during the meetup, you probably get the emails. If you're not part of the meetup and you're from the Google branch, we do run a DevOps book club that we meet, about every month and a half or so. It's good conversation. It's usually a pretty tight group, anywhere between like 10 and 20 of us. But we pick a book, we all vote on it, and then we have discussion. No one ever finishes the book, so don't feel bad if you did it. but there's still, a lively discussion, lots of good advice that comes out of it, and then we vote for the next book. So our current book is The Truth About Burnout, and you can see that at our Meetup website, and it's meetup.com/DevOps. And join us. And even if you don't get to read the book, just come for the conversation. Our next meetup is obviously going to be a Zoom meetup. But sooner or later, we'll get back to the in-persons, and it's just a really good group of folks, and lots of great discussion.
Cool, awesome. Thanks for sharing. Thanks for collaborating on this event. I'll go ahead and give my updates from the GDG side. It's a little bit interesting because I posted this on GDG Cloud. GDG Cloud has always existed, but formally the event has been sponsored as a Google GDG community. As of early February. The unfortunate side of all this is just as we were about ready to announce a bunch of meetups and campaigns, we are all, as you understand, in quarantine. So apologies if you kind of got like this weird notification where it's like, the group is now owned by Joel. So this is a good thing for us. So what this means is hopefully in the future we can have more like Google sponsors around the technology. If you're familiar with GDG Chicago, this could be seen as almost an extension of that, with GDG Chicago focusing primarily on things like Android, Firebase, web, Angular, stuff that you're kind of accustomed to. But we also heard that there was a lot of focus on, hey, we want more cloud events. So the good news is that hopefully it gives us the opportunity to have more events in the future, more in-person events that could kind of cater to both audiences. We still welcome everyone to come to both meetups. You're not restricted if you don't want to go to one or the other, but we're just, again, serving the community. We heard your request to have more in-person sessions, so that's what we're doing. So that's great. And this is one of our early ones that we wanted to have, but like I said, we decided to do a virtual one. No updates as of right now around the community side. I think we're still trying to figure out what this means for the remainder of the year in terms of schedule. A lot of our speakers that we were going to initially have kind of had to shuffle around. But all I can say is if you're not on the GDG Cloud meetup yet, follow us there, join us there. We're going to be happy to have you, and we hope to kick the tires here soon and get the ball rolling. While we're talking on the note of today's meetup, this meetup actually wouldn't be possible without the sponsorship of Armory, and I'm going to probably put Adam on pin here to maybe tell us a little bit more about Armory, what you guys do, and thank you so much for sponsoring us.
Yeah, sure. I know it's a kind of interesting time, so thanks for having us here. Armory, let me just actually go to the next slide here. So Armory is a company that helps support an open source tool called Spinnaker. So the talk that Joel and Lynn are going to give today are going to be talking about delivery with Spinnaker, this open source tool that Netflix developed about 10 years ago. Armory was created to help commercialize that and help organizations adopt and scale it. And so we really help organizations unlock innovation by making software delivery continuous, scalable, and safe. And I'm not going to go into too much detail here on the front end. I'd love to have you get a good understanding of the capabilities of Spinnaker through the talk that Joel and Lynn are going to give. And then we'll circle back at the end, just do a quick recap from our perspective at the end, so you can learn a little bit more about Armory. If you know what you see through Spinnaker seems really interesting, we'd be more than happy to have a discussion to see if it would help out in your organization. So a couple of logistics things. Everybody's on mute. However, the chat is open. Feel free to chat with other people if you are seeing somebody for the first time virtually here since the pandemic started. You know, we're hoping to make this kind of still a community-based event. So hit them up on the chat session. When the talk is over, Armory is going to do a quick presentation, and then we'll open it up to questions, discussion. Hopefully we can still have a little bit of that spirit of community here, even though we're all virtual. So feel free to post questions if you have, maybe a question that is urgent or you want to raise your hand or something. We'll try and keep an eye on the chat, but otherwise we're going to try and keep everybody mute just to, in the interest of the presentation. Cool. So with that, I'm going to go ahead and pass the controls over here to Joel.
Let's see. This will stop sharing others and continue. So let's try. Okay. Share screen. Okay, let me go full screen. This is a test. This is the thing. Will it work? Do you folks see the slides? Adam or Lynn?
Yeah, looks good.
All good.
Awesome. Technology is working fantastic. Don't worry if the slides are kind of choppy. We understand network connectivity, everything. We'll try hopefully have this recorded and shared. And we're also going to share the slides at the end of it all. And if you have questions after, it's not like we're going away. Shoot us a message on Slack or whatever. So first off, I want to welcome everyone to delivering Istio multi-region delivery to GKE using Spinnaker. A little bit about us. My name is Joel Vasallo. I'm the manager of Cloud DevOps at Redbox. There's my Twitter handle if you'd like to get in contact with me. And Lynn, who might be on mute.
Yeah, I was muted. Hi guys. So yeah, I'm one of Joel's employees. I'm a cloud DevOps / YAML engineer at Redbox. I deal mostly with, containerization, Kubernetes, and all things related to that.
He's made it to level 2 of YAML, so that's great. A little bit about Redbox. Our primary way you most likely know us is if you're joining us in the United States. We rent and sell physical DVDs and Blu-rays out of kiosks across America. Typically, they're found at your convenience stores, at your grocery stores, or usually at places of vending other things like stores. So we have a selection of Blu-rays every Tuesday at the box. We get new releases. So if you're a customer, whether new or old, thank you so much for your business. It really means a lot to us. In past years, past 2 years, we've been actually turning up Redbox On Demand, which is our on-demand streaming platform. This is available on the web, on your mobile devices, or on your set TVs being Vizio, LG, Samsung, and it's growing over time, whether you have Apple TV or Android, et cetera, et cetera. Again, we encourage you to check us out. We're putting a lot of hard work into it. We're really trying to revamp the platform and make it customer focused. So we hope to see you streaming some content soon. So the talk title is pretty impressive in itself, but you can't just kind of go to Istio Spinnaker just from day one, right? You have to start somewhere. How do we get to doing Istio? How do we get to Kubernetes? How do we get all this? So at Redbox, we had to start with just a greenfield, open day 0. The mindset was is if we build it, they will come. In mid-2018, about the time that I joined Redbox, we were committed to a mission of digital transformation. It's a term you hear a lot in the industry. What does that mean? Every company is doing something different. Are you just moving servers to the cloud? Are you moving servers to different aspects? Are you modernizing your platform? For us, it was 3 key deliverables across the org. And first and foremost, it was improving software delivery processes, migrating to cloud native architectures. So kind of retooling some of our applications to be more cloud native. A lot of the applications may have been written in a long time, like 5-10 years. It's maybe a good time to invest and say, hey, maybe there's some things that we did before that could be done better in the cloud, right? And that leads us into the last point of modernizing legacy applications. Some applications definitely have their purpose, but it's worth to again, review and see what are the new offerings in the cloud, right? Every year, technology, we know, outpaces itself. So it's good to be kind of ahead of that curve. The main thing we wanted to drive, and we've seen success in many organizations, and this kind of concept actually came from some of the talks that we've initially seen, like from folks at Netflix, is empowering your developers to own their code. At Redbox, our engineers are in charge of their applications end to end. There's not an operations team to like do the deployment for them. They click the button to deploy to production. They click the button to scale up their cluster. They define what their scaling requirements are. They have all this at their disposal. It doesn't mean that they're necessarily tossed into the wild of controlling their applications. We provide them the platform to, we as an organization provide them the platform and give them the best of practices in terms of security, best practices in terms of load balancing, et cetera, et cetera. Essentially, it can be described as developers, 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 developers. And we're building that culture where we empower our engineers to control their infrastructure. It's a pretty cool thing to see. So where do we start? We're a .NET shop, so we look towards .NET Core. The benefits of this is that it was container native. It gave us a lot of flexibility of still being in a familiar territory, but allowing us to focus on the future state of the containerization world, right? The containers are taking over everything. Almost every LinkedIn post I'm seeing is check out this tool for your container workload, right? And the primary partner was AWS. Why? It works. It was a great platform to start. We still are on AWS. A lot of our core platform is on AWS. It's a great platform, stable, and it was familiar. It allowed our teams really to focus on modernization and not so much Kubernetes craziness of like, how do I do YAML? How do I do scaling policies in Kubernetes? What are the metrics like? This gave a familiar landscape of Docker on EC2 on a VM behind a load balancer, and it works. It was great because it allowed our team to kind of take that next step up. So this is where the team, where we're a little seasoned, we're ready to play ball. All right, we've done containers, we know containers. We got Prometheus metrics, we got some application monitoring and all this stuff. All right, cool, but why do we have a VM, right? And this is also around the time that we laid out requirements for our on-demand platform. The requirements were you have a year to build, test, and deploy our new on-demand platform. Being what your US customers may be familiar with. So some of the core requirements, a year is pretty crazy, right? To say you could build basically an end-to-end system in a year was a lot of hard engineering hours. So for the folks on the call, awesome work. It had to scale to customer demand, be highly available. In the world of kiosks, I mean, we still operate them, but they're very autonomous. People have to walk up, interact with them. With streaming, you can turn your TV on, walk away from your desk, and it'll still be sending requests, right? So we couldn't be slowing down. We had to be able to meet that customer demand. So to do that, we had multi-region from day one. That was a hard requirement. The next thing is we have to provide reliable and extensible service-to-service communication. So things like canaries, A/B testing, controlled rollouts, circuit breakers. Very important because part of our infrastructure is that we're only running production for this. Our developers are running testing and developing against production. Because as we know, staging environments always contain fun data inconsistencies. And the last thing, again, true to our mission that I enabled earlier, developers are still in charge of their deployments. Now, this doesn't mean that we're giving kubeadmin to everybody to do kubeapply from their laptop with their lovely YAML files, but we'll touch on that in a second. So we extended our platform. Very similar how developers extend their platforms with different APIs. We added another flavor to our platform. We have our AWS path. Whether you want to go with it, you're still welcome to deploy to AWS. But if you want to deploy to Kubernetes, because maybe there's a requirement, maybe your service has to be multi-region, maybe it has to be highly available or whatever, you can deploy it to Kubernetes, and we use Google Cloud for that. And there's actually some nice things that we'll touch on, which kind of show some powers of Google Cloud that over AWS in some regards. So I'm not going to try and make this like a Kubernetes Docker talk, but what is Kubernetes? Kubernetes is an open source container orchestration system. It automates application deployments, it handles application scaling, and it also can control your service and node management, being what is actually running your container. It was originally from Google. I think we kind of all know the story, Borg, and it was from the CNC. It was initially at the CNC, well, it was donated to CNCF, and now it's a whole graduated project, and we all know it is, what it is today. That's a very popular project. But what were we looking for out of Kubernetes, right? We could have easily done a lot of everything that we've been doing on EC2, right, or Docker or in AWS. But what we were looking for was, again, the container orchestration piece. We were really just spinning up VMs to be a means to an end. We essentially just wanted to kind of peel away that VM layer and just focus on my container, my app, my service. No longer kind of like a Linux backend or a Windows backend to run your system, right? We wanted to have a little bit more control about rollout strategies. Kubernetes does a great rolling update that's kind of built into how Kubernetes does its deployments. There's also other strategies available to it. So it's kind of nice to have that built in. So that was nice. From a availability perspective, that was great. We wanted faster service scaling and load balancing. Again, we didn't want to wait for VMs, because when we were scaling, you can't just think about the container, especially in the legacy terms. You have to think about the VM. The Linux has to do its boot cycle, and then your container starts on top of that, right? You could use something like ECS, but at the end of the day, we wanted something that was open source in nature. If we wanted to move our platform to, say, a data center in the future, we can. If we wanted to move it to something like Azure in the future, we can, because we're in control of that. Centralized configuration management secrets. Again, we wanted to have a way to roll updates to our config files, because a lot of times changes to applications aren't necessarily application changes, but configuration changes. In addition to that, we wanted to have granular monitoring, not necessarily a Kubernetes thing, but just we wanted to focus primarily on our apps, and by using Kubernetes, it kind of let us focus on container performance. But the nice thing about it all is that we just wanted declarative configuration. Our platform essentially is driven on declarative configuration, even on the AWS side. But the nice aspect of it is that Kubernetes out of the box provides that in lovely YAML. Whether you like it or not, it's good. It works, right? So it's kind of the way it is. What do you mean by declarative? You have to define everything. What's the label? In this case here, it's Nginx. How many copies or replicas of that container do you want? I want 3 of them. What's the image, and what is the version of that image to use? Again, that versioning is a whole other topic, but again, you have to define all that. What ports should I expose, et cetera, et cetera. And typically when you're using Kubernetes, this is, again, committed into source. We'll probably touch more on this when we actually show the demo, but knowing that you have to define what you want and you will get what you want is really nice. Smallest part of Kubernetes at the end of the day is a pod. Pods, you don't typically manually create, they're handled via deployments. You say, I want to deploy 3 copies of this. And think of it as a logical grouping of containers, like a pod of whales is kind of how I describe it. That's the terminology of the nautical theme there. You can have 1 container, you get 3 containers, you get 5 containers, but that's all logically grouped in a single pod, which is ultimately a replica. Something to consider, though, is that at the end of this, let's say you were running Kubernetes on your own, you have to take into factor your container, your pod, but ultimately the node. And the node is typically the worker machine where your pods and ultimately your containers run on. Thing to realize, though, is nodes typically need to be repaired if they fall out of service. Like, let's say one of the Kubernetes kubelets stop responding. If you upgrade your master, you have to upgrade your typically you have to upgrade, you want to upgrade your node version as well and all the version dependencies on there. All in all, this is why we kind of went with GKE, because if you don't have to run a cluster, you shouldn't, because it's a lot of work. I mean, some companies have teams just dedicated to it, and on our side, we didn't really have people to just maintain Kubernetes clusters, right? We're just trying to rebuild our platform, get started from there. So it's simple as a G Cloud container create, a clusters create stage, and you get a cluster in Google Cloud. Some benefits of Kubernetes, horizontal node scaling. In the past, if you ran out of resources, at least in the AWS side, we would be spinning up VMs. VMs would spin up, deploy it to the VM. You need more VMs to do more work. Here, you spin up more nodes. Hey, my pods are in a pending state. Cluster autoscaler in Kubernetes sees this, creates a new node. Those pods now are on those new nodes, and now you have 3 nodes available. This is something that's great. It's out of the box in GKE. Really nice to see. There's also vertical node scaling. Again, this is the worker. So some workloads may not be able to be deployed to horizontally. Some workloads just want more memory. They want more storage. They want more CPU. Just feed me, feed me, feed me. Things like, I could think of things like SAP probably not being something fun to figure out how to load balance, right? Sometimes the option is, well, it ain't on 32 gigs. I'm going to give it 64 because it needs 64 gigs. Right, so there is vertical scaling for those more stateful workloads and monolithic applications as well. I touched on this again, but the deployment is essentially a wrapper around how many copies of those pods, your containers, you want running. So if you say, hey, I want three replicas of Nginx 1.79, it will make 3 copies of your deployment. Just something, I'm kind of going over terminology because Lynn and stuff will go over this a little bit more in detail. Within Kubernetes also, you get pod autoscaling. So you're able to scale with a simple command of kube autoscale my deployment, named foo. I want a minimum of 2 and a maximum of 5 at CPU 80%. What that means is when my CPU ticks over 80, I want to scale 2 more pods, right? So in this case, you can see there's 2, and it'll scale up to n greater than, less than or equal to 5. Out of the box, you get CPU and memory, but you could also extend this with custom metrics. So things like, I don't know, you might be able to do something like stream starts per second and say, hey, if we're seeing over 100 streams per second, add another box. It's something that can't be captured. Maybe there's a bug, maybe there's a deficiency. You could scale on maybe more product side, application side things that you define as well. And to kind of put a bow on it all is the concept of a service. Service can somewhat be seen as a load balancer. It's essentially that all deployments get a label. In this case, label is Nginx. All my pods with the label of Nginx are then put in essentially like a load balancer called service B in this case here. And you see that despite them being distributed across multiple nodes, they are still within Kubernetes seen as one, and Kubernetes knows how to load balance that to whether it be node A, node B. The nice thing about this is, as we know, nodes, VMs, everything breaks all the time. If this first node was to disappear, we would still have availability on our second node as Kubernetes works to reschedule the dependencies and stuff behind the scenes. And this is one of the nice things within Kubernetes that we really have seen in time in the past few weeks here too, as with the COVID increase in traffic. When using services, and I'm not going to go too much into detail here, you get the ability of doing things like service discovery, and you can use those labels to do service discovery and service meshes, and we'll kind of touch on that in a second when we get to that part. So the multi-region bit, I know the multi-region was in there. We use Google Cloud's. Google Cloud is out of the box, globally built. A lot of their things are with global in mind, be it their data layers. There's a few things in there like Spanner, Firestore that are global in nature, which enable a lot of creative and awesome solutions. And that's things that we're leveraging. But also on the Ingress, you can do global MultiCluster Ingress. So this is essentially a load balancer that spans across the world or wherever people are sourcing from. And using Google's backbone, you're able to route them to the closest point of presence that you may be in. So in our case, you can see this as, this is kind of what you'll see when you have it configured. Our North American traffic, a lot of it's going to east, part of it's going to west because probably people are just waking up or maybe going to bed or whatever. And then if you have the European data center, it'll route over to Europe. It'll kind of balance your traffic. So that's really nice. So essentially you basically make 3 Kubernetes clusters, east, west, and Europe, or wherever you may be. And you have a load balancer that sits in front of it, and it just knows how to route to each of those clusters, ingresses. And we'll touch on that as well in a future slide. So I went really fast. I said I wasn't going to make this all about Kubernetes because I think a lot of the cool stuff is actually within Istio and within Spinnaker. Kubernetes, we got it. So check 1, right? We needed to have a reliable, highly available multi-region environment. Gave us the availability, done. Multi-region, we got the Google Cloud. Scaling built into Kubernetes. We're done, right? We can put our feet up. Customers are happy. Well, this is when your boss comes and says, hey, what about that service discovery, right? Like all we're doing is deploying to prod right now. How do we do balancing between 2 versions of applications? All right, so I guess we got to get back to it. And this is where we picked up on Istio. Istio is a service mesh that we picked at Redbox. It's essentially a service mesh. Again, I'm not going to go into too much into the concepts of what a service mesh is, but it essentially enables service-to-service communication between your east and west traffic. It handles things like traffic routing, security, observability in terms of communication, and extensibility. We'll probably be going into very much detail of the first 3, not so much into extensibility, but the concept of extensibility is that Istio is built upon the concept of proxies using Envoy. There's a lot of great technologies out there that extend Envoy. Thus, if you're able to extend Envoy, you can use Istio to do that extensibility there too. The beauty of Istio is that you don't really have to write or really touch your code to kind of get any of these cool traffic routing things out of the box. And you'll see Lynn kind of give some demos of this too in a few minutes here. So why Istio? Why did we pick Istio? There's tons of great service meshes out there. Well, one, at the time, again, 2018, Istio was kind of the hot topic at the time. I mean, service mesh was growing for whatever reason. I mean, Google Cloud also natively supported it in beta form at the time. So we kind of went with it, and it was actually pretty good to start with. So we got out of it routing rules, retries, failures, and fault injection. So being able to do that canary-based routing that we discussed earlier as a requirement. We got policies and security layers via dynamic API. So we're able to dynamically route traffic without having to restart our deployments, right? So we were also able to get secure service-to-service communication via MTLS, which is something that Istio does for you out of the box. You don't have to provide your own certificates. It'll provide that via some layers that we'll talk on here as well. We were able to instill rate limits and quotas. Hey, if I'm getting bombarded by this one pod over 500 requests per second, tell it to back off. Hey, take it easy. Stop sending me so much traffic. I have to catch up, right? I want to have a circuit breaker. My service goes down. Like I said earlier, things break all the time. When that service is down, do we just bubble that error up to the customer? No, we should probably try and give them a more graceful response so we can actually control, like, hey, sorry, this didn't work, or maybe just don't even fail the whole process, just record it and move on. We wanted service-to-service observability. So as I mentioned earlier, Istio leverages proxies to do its communication, and I'll kind of show a diagram of this in a second. But by doing so, you actually get some nice things. So you get out of the box, you get logs, you get metrics and traces in your requests. So whereas before you had to say, hey, developers, could you add a metric for the response time of this API? Hey, developers, could you add a log every time this fails? By leveraging the proxies, you're actually able to kind of collect that, and Istio natively does this for you. So the diagram, if you kind of Google Istio architecture, you kind of see, and it's not, I'll be straightforward, it's not actually up to date right now, and I'll kind of touch on that in a second, is this. Very intimidating. You look at this, and I know I looked at this and I'm like, wow, this is way too complex. But if we break it down, it does make sense. The first thing is, typically you can use Istio to be an Ingress proxy. So you can have a, like a gateway that essentially listens. You can have your OIDC, your authentication layer up at the edge here to kind of either reject or accept traffic. But the nice thing is that as traffic is flowing, service to service gets MTLS via the Citadel certificate issuance. So basically every time a new pod gets deployed, Istio spins up a proxy and initializes it saying, hey, give me a certificate, such that communications between the applications is secured via MTLS. The hardest thing about Istio is you have to take back and say, I'm no longer talking service A to service B, I'm talking to service B's proxy. So if we walk through a flow, service A talks to its proxy, which issues a request to the proxy on service B, which on its behalf talks to service B. And you'll see this in the demo as you'll be like, why is it responding with Envoy? This is the reason why, because you're no longer talking to your Tomcat backend or your .NET Core backend, right? You're talking to a proxy layer. I'm not going to go into too much internals of the Istio control plane because this actually got dramatically simplified. But on the egress, you're also able to do things like jot, modify response headers, modify request headers. You're able to add headers as well. So basically, at any layer, you can kind of get, you can essentially make the response or request do whatever you need to do. And then on top of it, you get the reporting aspect. Every time it gets a request, it reports a log, it reports a metric. And these can be exposed via some pretty cool tools, and we'll touch on that as well. So taking a look at this is Istio in 1.4. Istio 1.4 was current until early March of this year. You see that there's a lot of microservices that kind of link together here. A lot of things and a lot of the complaints people had about Istio is that there was way too much microservices. When one of these broke, you were kind of like, was it Mixer? Was it Galley talking to Mixer? Was it Citadel somehow not being able to talk to my proxy? And we were also bit by this as well. So with that being said, Kelsey had one of his prophetic tweets back in 2017 that by 2020, some monolithic applications will be back in style after this discovered the drawback of some monolithic apps. And he was kind of right. The Istio project kind of simplified this, making just one binary called Istio-D. Because at the end of the day, you will not only have to manage one layer of a binary versus all these distinct microservices that you may not know how to operate. Again, now you only have to troubleshoot one monolith. So, but now it looks something like this. You have your Ingress traffic talking to a proxy. You have Istio-D that does your certificates, it does your configuration, it does your service discovery, but you still have the same service A talking to service B, proxy talking to the app, and same thing with egress. Much easier to do. Upgrades have gotten so much better. If you haven't looked at Istio before in the past and you just kind of like, that is way too complex, definitely take a look. It's gone a long way since. And I've done a lot of talking, so I'll kind of hand it over to Flynn.
All right, can you guys see my screen?
Yeah, I can.
All right, very cool. Okay, so Joel kind of talked about, what Istio is, how it works, and why we chose it. And we wanted to take this opportunity to kind of talk about how you actually configure routing in Istio. And you're going to see it a little more in depth during the demo, but we wanted to touch on it now while we were already on the topic. So if you're not familiar, a custom resource definition, or CRD, is a way to kind of teach Kubernetes and the Kubernetes API new tricks. So you can kind of show Kubernetes how to speak and how to configure Istio. And then just like you have a YAML file to create a deployment, you have a YAML file now that you use to configure Istio. And so you're not actually interacting with Istio directly. Instead, you have this YAML file that does a certain thing, and you pass it off to the Kubernetes API, which then passes it off to Istio. And that's a really cool feature because it means things like Spinnaker, which know Kubernetes but don't know Istio, can suddenly work with Istio right out of the box because they both really just understand Kubernetes. And that's sort of the integration layer. So there's 3 main CRDs that we're going to talk about. And these are really the ones that when you're dealing with routing in Istio that you're going to deal with the most. The first is the gateway. The gateway is going to be used to expose services outside of the Kubernetes cluster. In other words, if you have internal pods and you use Istio to handle routing, and you have some, say, internet-facing customers or something that need to communicate with those pods, the gateway is how you're going to actually set that up. Sorry. All right. So next up, you have the destination rule, and that's going to define a list of destinations for routing traffic. This one's relatively static. It's also sort of misleading because it's singular, but actually in a destination rule, you're going to define multiple destinations. Your destinations are going to be per service. So if you have a destination rule for service A, and then say you have a canary and prod, then inside of that destination rule, you're going to define how to send traffic to the canary and to the prod. It's sort of up to you how you want to do it. You can also do like V1, V2, V3. It really just depends how you've configured Istio. But those you won't really change too much. Most of the magic really happens in the virtual service, which is the one that we're going to see the most. And the virtual service defines how and when to route traffic using things like headers, pod labels, so the actual labels on the pods in Kubernetes. You can also do a percentage, so send 30% of traffic to the canary, to prod, or to V2, or whatever it is you want to do. And it does that actually by referencing the gateway and the destination rule. So independently, the gateway and the destination rule really aren't doing much. It's the virtual service that kind of brings this all together. All right. So I promise we won't show you too much YAML, just one more slide after this, and it'll be simple, I promise. So defining a gateway and a destination rule in Istio. On the left, if you look, this is the gateway. And if we move down to the first comment, number 1 there, the first thing you're going to do when you set up your gateway is you're going to define a selector for Istio to find the gateway. 9 times out of 10, you're going to have exactly what we have here, which just says Istio equals Ingress gateway. You can technically define multiple sort of Ingress proxies, and then you can say, okay, proxy 1 should use gateways, you know, A through B and something like that. But more often than not, you're just going to have one proxy for your gateway, and so you're going to have something like this, which is the default selector. But where you really start to get into the details is with step 2, which is where you define the hosts and the protocols and the ports for the Ingress. So something like demo.com with a port of 80 using the HTTP protocol. And keep in mind, this is for traffic that's outside of your cluster and going in. So all of this is going to be, you know, external. So internally, your pod may run on, say, 8080, but externally, you expose it via port 80. Next, then, you've got the destination rule on the right. If we look at number 1 here, this is the destination host name. So this is kind of where we switch from something like demo.com, which is our external name, to the internal Kubernetes-based DNS records. If you're not familiar, basically SVC or service.cluster.local is just the reserved DNS name for a Kubernetes service. And then demo.demo just means the app is named demo in the namespace demo. So this is going to be created automatically for us by Kubernetes, which is why we're going to use it in Istio, because then Istio can kind of hijack that traffic that's already setting up and working inside the cluster. And then you can see there's 2 subsets here. So we define a prod one, and we define the label selector as app equals demo and environment equals prod. So these labels are going to be present on our pod workloads. And then these canary labels are going to be present on the canary pod workloads. And that's how Istio is going to determine when and where to send pods, right? But those are really just static rules. There's really no logic in there. So to really tie it all together, you need the virtual service. So ignoring the YAML on the left there, let's look at the right because it's a little easier to understand. So let's take a scenario where you've got multiple end users, most of which, like the 3 on the left, they just want to make an HTTP call. It needs to go into the cluster and it needs to go to prod. Really simple use case, right? But for testing, say like in a canary, you need some users to be able to do something like set a header environment equals canary, and they should then go through the Istio gateway and hit the canary workloads or your staging environment or however it is you want to define it. So it's basically if no headers are set, go to prod. If the canary header is set, go to canary. So if we look at the left here where the YAML is, we can actually see how this works. So the first thing you're going to do in the virtual service is you're going to define that gateway. And if you don't do this, the traffic will hit the gateway, but Istio is not going to know how to route it, right? And you can have multiple gateways in a cluster. So this is how you kind of say, hey, for demo gateway, I want the demo virtual service to be included in your routing decisions. Next, you're going to define any hosts that should apply to this virtual service. One thing to keep in mind is that when you create a virtual service, you're defining routing rules both for external traffic coming into the cluster and for just internal traffic, say service A calling service B with no real end users from outside of the cluster involved. So you need to include both the internal and the external DNS records. You can do wildcards here. I wouldn't recommend it because eventually you're probably going to have two virtual services with overlapping wildcards. Istio offers no guarantees when that happens, and you're going to see some really, really strange results. So next then we're going to define the actual rules. So looking at number 3 is where we're going to define this header canary. So we're saying here's our route, and use this route if there's a header named env with the exact value canary. And if there is, send it to the destination host, again, that internal DNS record with the subset of canary. You guys hear those fireworks? Jeez. Okay. And then fourth, you have a default route. This one doesn't have a match rule. And this one needs to come last because you're going to define these in the order that they need to be evaluated. So if you have this one here with no match rule and it's up top, you're going to accidentally send all of your traffic to the wrong place. Okay, so I hope that all made sense. I hope it wasn't YAML overload. Let's move on and let's bring it all together. So Joel talked about a lot, I talked about a lot, and let's really, let's recap. So Istio uses Envoy proxies to route traffic based on the configurations you have given. So out of the box, it's not really going to do much. You need to install it and you need to start configuring it to do whatever it is you want to do. But the use of Envoy proxies really means it's agnostic to code, right? So C#, Python, Java, it really doesn't matter as long as they speak something like HTTP, gRPC, some sort of network layer protocols. The service mesh is going to give you really great security out of the box. You've got stuff like mutual TLS. You've got, let me look at chat. Yeah, but my neighbors were shooting off fireworks. Maybe you guys couldn't hear it. Okay. So the service mesh is going to give you great security out of the box. You've got mutual TLS. You get a lot of observability because it's basically just a proxy. And so you can see everything coming in and going out of those proxies if you want to. And finally then, Istio is open source. It can run on any Kubernetes cluster inside or outside of Kubernetes. So you can actually run it like in EC2 if you wanted. It's going to be a little more work. It's definitely easier to set up in Kubernetes. But because of that really open and open source nature, it's really easy to run and there's no vendor lock-in, which is really great. All right, so I'm going to pass it back to Joel here.
Cool. This is so far so good. Lynn, the fireworks for the end of the presentation, man.
Oh, I'm sorry. I told him to wait.
We must be off time. Let me know when you guys can see my screen. Lynn, can you see my screen right now?
Yes.
Great. So we got it. We got Kubernetes. We got our availability. We touched on it. We have multi-region. Cool. We have Istio. We have our routing canaries. We're able to do A/B traffic and route within the cluster however we want. So we're done. That's it. It's over. Well, that's again where the boss comes in and says, wait, what about software delivery? Why are you kubectl applying -f YAML test.yaml 30 times in a day? And why do people have admin to this cluster? Let's just take a look at this. One file, not a big deal. One developer, one team, not a big deal. You know what? I'll just dedicate my day. Anytime they ping me, I'll do a kube apply. Easy. Oh, wait a second. That team grew, and now that team is about 30 people. There's about 15 files that we have to apply. Maybe if we just stitch one giant YAML, that's what we'll do. We'll make one giant bash script and just stitch that YAML together. Boom, bam. We'll be set up. Okay, now it's getting crazy. We have over 50 YAML files that are just kind of getting piled into the team. Everyone is unique. There's no longer really a way to templatize this. We need to make this stop because at this point, you probably feel like this. You just try to change one thing and then everything just kind of keels over because your templates just don't scale. So we needed a way to solve software delivery into Kubernetes. And for that, we turned to Spinnaker for that solution. So a lot of you folks may know about Spinnaker or have heard about Spinnaker. Spinnaker's come a long way. It was initially a Netflix open source project in late 2015. It's still open. It's a very active community, and it's always growing. In fact, they just had their recent gardening days, like a hackathon of sorts, 2 weeks ago. It was actually a really fun activity to be a part of. A lot of folks sharing and building features and grooming the backlog of the project. So if you're interested in that stuff, check it out. One of the main reasons we went with it is because it provided a singular interface into our cloud infrastructure and essentially give us a platform to extend and build on. Whether you're running in AWS, whether you're running in GCP or any other cloud provider, it gave us a common way to interface with those APIs of those vendors, those cloud providers, thus making it so we're not really coding against one or the other, we're coding against Spinnaker, and it was actually pretty nice to see, and we'll probably show that off here too. It supports Kubernetes. GKE is great, but at the end of the day, we do not want to lose sight that at the end of the day, we want to target Kubernetes, not GKE, not EKS, not AKS. We don't want vendor lock-in. Automated canary analysis, and we're not going to touch on this today, but there is support for some awesome automated canaries, and maybe we'll have a slide on that if I recall. The benefit of Spinnaker was it's also now in a neutral party in the Continuous Delivery Foundation. So it's no longer, it was donated by Netflix into the CD Foundation. I believe Jenkins as well is in there, and Tecton and Jenkins X. So now folks like Microsoft, folks like Amazon are contributing to the platform because it's in neutral hands as well. It's no longer kind of like a Netflix thing, which is great to see. It has a large user base. We're one of the main users. We're contributors as well, but a lot of great companies, Under Armour, Armory, GoGo, can be contributing to the platform as well. Grubhub as well as using it too. So definitely a lot of large companies using it, which is great. It's multi-account, multi-region, multi-cloud right out of the box. In the background, if you can kind of see it, you'll see that we have a deployment that is in AWS on the bottom, but we also have a deployment that's in GKE at the top. Visualizing that in one spot means developers don't have to context switch saying, oh, I have to go to Jenkins for my AWS deployments and then go to Octopus deploy for my data center deployments and go here for my Kubernetes deployment. No, it's all in one spot, and Lynn will kind of show that off in the live demo, so I'm not going to take away from that. At the end of the day, the main thing that Spinnaker brings is it visualizes your end-to-end delivery process. So what does it mean to get to production? And again, this means different things for different people, different companies. But basically, it gives you a way of saying step 1, step 2, step 3, do these 5 steps. Step 4, do this 1 step. And you'll kind of see that again in the demo, but visualizing your software delivery. And by doing so, it lets other people kind of just accept or deploy and hit the OK button to basically single click deploy into production. And we'll get to that in the demo. But Lynn, do you want to talk a little bit more about the flow and maybe the demos to just kind of frame it for everybody?
Yep, definitely. Okay. Can you guys see my screen now?
Yes, there we go. It's full screen now.
Perfect. Okay. Okay, so we're going to do a Spinnaker demo. In the demo, we're going to deploy to Kubernetes. We're going to do some stuff like integration tests. We're going to use Istio. But before we get to that, we just want to kind of talk about what the full flow of Spinnaker would typically look like, because we're going to focus just on Spinnaker in the demo. Spinnaker is super flexible, so this is one of about 50 ways you could configure it. But Spinnaker is not a CI tool. It's not a source control tool. It's not going to host artifacts for you. So you're going to have to define some of these things. But more often than not, you've got something like Git. You've got a CI tool like Jenkins, I don't know, Concourse, Travis CI, something like that. You're going to send your artifacts, a Docker container in this case, to a registry. And you're going to trigger Spinnaker off of one of those things. You could trigger it off of the change in the Docker container. You could trigger it directly from the Jenkins build, webhooks, pub/sub events, like all these crazy things. But you need to trigger Spinnaker in some way. And when that happens, a Spinnaker pipeline or multiple pipelines is going to kick off. And Spinnaker is basically going to take all of that YAML that you used to have to manage manually, and it's going to apply it into Kubernetes. And because Spinnaker knows how to speak Kubernetes, it's going to look at what you're applying, and it's going to actually monitor and wait on various phases. So for example, a deployment, well, a deployment isn't really successful until all of the pods come up and they're healthy. Spinnaker knows that, and it's going to wait until those pods are healthy to continue to the next step. So Spinnaker is going to gradually deploy the changes to Kubernetes, and it's going to handle all the YAML so that we're not sitting there editing text files and stuff ourselves. Okay, so it is demo time. So we're going to do a Spinnaker demo with Kubernetes and Istio. A couple of requirements that we set out for our demo. We want 0 downtime. So we're going to promote something through Canary and into prod, and we want that all to happen seamlessly with no 500s, with no 404s or 503s or anything like that. It should be perfect, right? We're going to use a Canary to slowly roll out those changes. During the Canary phase, we're going to do a 50-50 traffic split between prod and Canary. We're going to trigger some automated integration tests or functional tests or whatever you want to call them. And both the automated test and anyone who might be manually testing, like a developer or a quality assurance team, they're going to need some way to target both Canary and the production pods directly. Because if they're trying to do some sort of test and half the time they're hitting prod and half the time they're hitting Canary, they're not really going to have really reliable tests. So we need to give them some way to opt out of that 50-50 split. So let me switch over here. So this is Spinnaker. This is Spinnaker. It's running inside of Kubernetes, and we're going to deploy to Kubernetes. We've got one application called GDG demo app, and we've got one pipeline deploy microservice. For example, at Redbox, we may have 3 or 4 of these, one per cluster or something, you know, so that way devs can deploy to the West cluster and not the central cluster or something like that. But just for the purposes of the demo, we have one deploy microservice pipeline. So let's go into configure and let's actually look at what we're doing here. So the first phase is going to be these 3 steps right here, which is Canary deploy, Canary Istio routes, and Canary run tests. Then we're going to promote to prod. This is a manual wait step, so it's basically just going to pause until someone, me, goes in and says, okay, continue with the pipeline. And then we've got those same 3 tests, but now we're in production. And then we've got a Canary cleanup, which is basically just going to delete the leftover Canary resources so that we can free those, you know, CPU claims and memory claims and stuff up for other pods because they're no longer receiving traffic. Let's actually look at what the Canary deploy is going to do. So we are deploying a kind deployment. This is basically just saying, hey, I want a deployment. It's going to live indefinitely. We want 3 replicas or 3 pods, and put some labels on there like app equals demo and environment equals Canary. And then just for the demo purposes, our image is a REST API. It has one endpoint, and that endpoint just outputs the value of this environment variable demo environment name, which we've set to Canary. Basically just so we can verify that Istio routing is working correctly, which means when we say, hey, Istio, send me to the Canary, we should see the REST endpoint give the response Canary back. Next, we're deploying a normal Kubernetes service. This one's pretty basic. We're just saying, hey, we're hosting a service. It's on port 80. The name is demo, and we're going to put this in the namespace demo, which is where that demo.demo.service.cluster.local DNS record comes from. So once it does this, it's going to wait. It's going to take something like 30 to 40 seconds for those pods to become up and become healthy. And then it's going to move on to the Canary Istio routes stage. More YAML, like I said, and we see this destination rule. So again, this is an Istio resource configuration, right? But Spinnaker doesn't know what Istio is, but since we can just send these YAML files essentially to Kubernetes, suddenly we can do Istio stuff in Spinnaker despite the fact that it doesn't really know what that is. So the destination rule is pretty simple. You'll see that internal DNS record, you'll see those same labels that we saw before, app equals demo and environment equals prod. If we move down to the virtual service, it gets a little more complicated. So first off, like we did in the PowerPoint slides, you can see the gateways. You can see this demo gateway. I've created this manually in the cluster, so it's not in the pipeline. And I'm not really going to talk about it, but this gateway doesn't actually exist. This is just a reserved keyword in Istio. In some cases, like when you use source labels down here, you have to include this keyword. I don't really know why, to be honest. They don't explain. They just say in the documentation that you have to, so we did. So next up, after we define our gateways, we define our hosts. So again, we've got the internal and the external DNS records here. Let's move on to the actual routing rules. So the first one is our Canary routing rule. So we've got 2 rules in here, and because they're defined separately as arrays, it's an OR. So the first condition is if the header xdemo environment has the value Canary, or if the source labels has the label demo test environment Canary. What this means is basically when a pod creates traffic, Istio can look at the pod that created that traffic and it can read the labels because Istio understands how to interact with Kubernetes. So what we can do when we trigger our integration tests, which are going to run as containers, we can add these labels automatically, and then we can reconfigure what HTTP endpoints those integration tests are hitting without any code changes. So now we've got two ways to target the canary: the automatic way through the Kubernetes labels, and also through a header for those of us that are outside the cluster, like a developer or quality assurance person that basically just needs to test something really quickly. We've got a second rule, which is basically the same thing, but instead of canary, we've got prod values. And finally, we've got our default route, which sends 50% of traffic right here to the canary and 50% of traffic here to prod. So by default, traffic should be going to prod about 50-50, but if we want, we can opt out of that, and the integration tests in canary mode should always go to canary, integration tests in prod mode should always go to prod. Okay, so just to verify, let's go to our run test step. This one is going to be a Kubernetes job. We didn't really touch on it. It's really simple. A job gets one pod. Inside of that pod, you can have multiple containers. And unlike a deployment, which is something like a REST API, some sort of service that needs to live forever, a job does one thing and then stops. Both Spinnaker and Kubernetes understand that a job should do one thing and stop, and they also look at the exit code that's used by the code running in those containers. And if that returns a 0, then it means the job was successful. If it returns a 1 or higher, that means the job failed. So this could be anything. This could be like a one-time data transfer, a SQL migration or something. But in our case, we're running an integration test. So what we want to do then is we want our code to return a 0 if the tests have passed, or a 1 if the tests have failed. Both Kubernetes and Spinnaker are going to pick up on that. And in the case of Spinnaker, if our tests fail, it's going to stop the pipeline right away. And just to verify, here you can see that label, demo test environment canary, which tells Istio that it needs to route any HTTP calls out of this pod into the canary endpoints. Okay, so I promise we're about to get started, but there's one thing we want to do. So the integration tests are going to verify that Istio is working internally, because it's going to deal with one container calling another container within our cluster. But we also want to verify it from outside the cluster. So we've created a couple of shell scripts. It's basically just going to loop and make calls indefinitely. We've got 3 of them. The first one is going to ask Istio to be routed dynamically. And it's doing that because it's not setting any headers, right? So it's just saying, hey, whatever the default route is, I want to use that. So let's get that one started. All right. So you can see right now, all of the responses from the REST endpoint are saying environment name is prod. And that makes sense because we don't have a canary active. The next one, we're going to set the xdemo environment equals to canary. And at first, we're going to see this returns the prod endpoint, again, because we don't have a canary active, so that's expected. But what we should see eventually is that that actually switches over once we apply our Istio rules, and we'll start seeing canary responses. And that should happen seamlessly with no errors. The curl script shouldn't stop running or anything like that. Finally, we've got one more, basically the same thing, but now we're requesting to go to prod. So this one should never, ever say canary. So I'm just going to let these run in the background. And while we're deploying through Spinnaker, we're going to come back and we're going to take a look at them. All right, so let's go ahead and kick it off. We're going to hit start manual execution. And the first thing is that canary deploy step. So let's click it. All right, so we're about 10 seconds in, and you can already see those YAML declarative files that we put into Spinnaker have already shown up here. You can see the service is available and then it's stable. And you can see the deployment is not yet stable because it's yellow. But it should come up in just a few seconds. There we go. So Spinnaker is basically polling the Kubernetes API and providing us with updates. So we can now see that there's a new replica set, demo canary, and there are 3 replicas, which is what we asked for. So that's good. So we're exactly where we should be. So let's move on to the canary Istio routes then. You can see the virtual service and the destination rule. If you want, you can click on the YAML button here, and it's going to show you the YAML as it's in the cluster. So you can see a couple of things like Spinnaker adds some annotations. This is just what Spinnaker uses to kind of associate a particular object in Kubernetes back to our demo project. You can see a lot of extra stuff provided by Kubernetes, but if we scroll down, we'll see the YAML that we actually created. Okay, so our canary Istio routes are applied. Everything is stable. It's green. It's looking good. Let's go back to these curl commands. So the first one, routing to prod, we're still seeing prod responses. Let me make sure I'm scrolled all the way down. Yep. So that makes sense, right? In this particular case, we're saying, hey, Istio, we always want to go to prod, even when there's a canary. Well, let's go to the canary one. All right, let's actually go to the routing dynamically one. Scroll all the way down. There we go. So this one's routing dynamically, remember. So we're not setting any headers. And you can see it's about 50-50. So we're seeing a lot of responses that say prod, a lot of responses that say canary, and that means Istio by default is now routing our traffic 50-50. So looking good from outside the cluster. And let's double check the canary one, scroll all the way down. Okay, so we can see the canary header one is still routing to canary, and that's good. And it was, it was routing to prod originally, but now that we have a canary, it's routing to canary. Okay, so our integration tests have run now too. Took about 26 seconds, that's pretty good. And one cool thing about deploying a job through Spinnaker is that it recognizes that job. It stops the stage if an error occurs, but it also gives you this nice little console output link right here. So let's click it. You can see 3 tabs up here. So these 3 tabs are the containers running in this particular pod. You can see Istio and init. This is just run at startup. It takes like less than 1 second, and that configures Istio for us. So there's not really anything interesting in here. We can see the Istio proxy. That's running. We can see a lot of logs. These are from Istio. Again, nothing super interesting. But if we go to the integration tests, what we should see is that all of the responses say canary and all of the servers say envoy, right? So let's look. So looks good. Let's scroll down. Yeah. So even though we didn't make any code changes, this code has no idea what integration tests really is. It's just making a HTTP call. It's really not aware of a canary or prod or anything like that. But because Istio looked at the labels on the pod that we installed into the cluster and routed, it's getting only canary responses. And the server here saying envoy, this just verifies that the response header in the HTTP call has server envoy, which means this isn't a fluke. We didn't randomly get all canaries. We're actually going through envoy. If we saw something like Kestrel or Apache or Nginx, then, you know, okay, we got lucky, but we can say 100% certain that our routing is working correctly inside the cluster as well as outside of the cluster. Okay, so looking good so far. We're in the middle of a canary. Let's go ahead and promote to prod, right? Everything worked, our integration test passed, we manually verified everything outside the cluster. So the prod deployment, pretty much the same thing. So let's give it a sec. And actually, while this is going, let's do something. One other cool thing about Spinnaker is it kind of gives you like a lightweight monitoring view to look at your infrastructure. So let's go to the deployment, let's hit details. And now we're on the infrastructure tab up here. And we can see we have a deployment named Canary. We can see we have a deployment named prod. We can see how many pods there are. So each box is a pod, and green means they're healthy, while red would mean they're unhealthy. We can see lots of stuff from Kubernetes, like the labels, what Docker image is running, and things like that. We can click on the pod and get a little more detail. We can see the console log from the REST service as well. So let's go to the demo pod. And so now you can see my demo controller. That's the code actually responding to the HTTP calls and things like that. So really quickly, we've gotten a bunch of information about the health, how many pods we have. We've gotten to look at some console logs and things like that. So let's scroll back up. Go back to the pipeline view. We should be a little further. Yeah. So our deployment went well. Everything's healthy, everything's stable. The prod Istio routes, everything works, everything's healthy, everything's stable. We're running our integration tests. But since this Istio routes step is green, we can go back to these curl commands and verify that everything is working as it should. Now keep in mind, there's technically no canary active right now, so we should be back where we started. So let's scroll down. This one, remember, is routing to prod. So we're setting the prod header. We're getting a prod response. That's easy. This one, remember, we were saying, hey, send me to canary, but there's no canary active right now. So the only rule that Istio knows is that prod one. So we're now routing everything to prod. So that means our Istio routes are working from outside of the cluster as well. If you wanted, you could do something like return a 503 if they request a canary and there's no canary. What we do at Redbox is we basically say, okay, it's a request. So you're saying, I would prefer to go to the canary, but if there's no canary, then prod is better, right? And finally, if we go to the routing dynamically one, we're now seeing only prod responses. So we're no longer seeing that 50-50 traffic split. Okay. Back to Spinnaker. Let's look at the tests. Sort of a weird quirk of the Spinnaker UI. We deployed the same job twice. And in the Spinnaker UI, you're going to see both runs, basically. So this one's 6 minutes ago. This is actually our canary tests. We want this second one, which was 1 minute ago, which was the prod tests. So let's click it. Let's go to the integration test tab. And so now we should see everything is server envoy and environment is prod. And that looks good. You can see all tests passed. So now we know, without a doubt, traffic is working correctly inside of the cluster as well as outside of the cluster. We triggered some integration tests automatically. There was no downtime because all of our curl commands are still running. And finally, we did a canary cleanup, which deleted all of those pods in that deployment with the canary label. And that way, prod has more resources to scale now that the canary is no longer receiving traffic. Let's go back to the slides, make sure we covered everything. Okay, zero downtime, check. Use canary to roll out changes, check. We did a 50-50 traffic split. We had some automated integration tests that ran inside the cluster. And we also gave certain people and those automated tests a way to opt out or a way to be routed dynamically without that 50-50 traffic split. So that's pretty cool. This is very similar to our production setup at Redbox, but this actually wasn't the vision. So there's something further we wanted to do, and we're still planning on doing it, but it's pretty complicated. So there's still kind of a problem here, right? So we ran some integration tests. They're functional tests, right? So they kind of test the happy path, but there's still a chance that maybe we're seeing increased error rate. Maybe some user who clicked the same button 50 times in the new version, like actually did something 50 times when that didn't happen in the old version. Maybe it's just slower. Maybe there's just a latency issue. Right now, the pipeline depends on someone going and looking at something like a Grafana dashboard or, I don't know, Dynatrace or whatever you use for monitoring. And that's kind of a manual step that you can't really automate currently. But Spinnaker does have a way to do this. So what comes next for us? Automated canary analysis is something that we had in our vision. Still something we want to do, but it is pretty complicated. So what Spinnaker can do is you can basically tie Spinnaker to your metrics, Prometheus, Stackdriver, Datadog, whatever it is you use, and you can give it a series of metrics to evaluate both in your canary and in your production workloads. You can do a sort of a silent canary, which basically just gives a recommendation whether the canary should go to prod, or you can actually have it fail the pipeline. So you can do things like, did CPU resource go up in the new version? Were there more errors per request? Did we need more containers, more pods for the same amount of traffic? Things like that. So the things that typically slip through the cracks because you can't really functionally test them. You know, running a curl command isn't really the same as like dealing with real prod traffic and things like that. So we're not quite there yet, but this is definitely something that we're looking at for the future. And if you guys end up checking out Spinnaker, I would definitely check out, there's quite a few blog posts about the canary analysis, and it's really, really cool stuff. Okay, so I'm done for a couple of minutes. So let me turn back to Joel here.
Let me get back to sharing here. And when I go here, the slides are, all right. Can you all see the Zelda stuff? Lynn, you see it?
Yep.
Yep.
Great. Cool. So we did a lot of talking. We covered a lot of things. There's a lot of things that we use in our day-to-day to kind of make everything that we just kind of presented successful. So it's dangerous to go alone, and we have to kind of mention some tools that really we use in our day-to-day to help this all work. First off, if you're in a Kubernetes environment and you don't know what K9s is, do yourself a favor and brew install this now. It's amazing. It kind of lets you visualize your entire cluster from a single pane of glass. So instead of doing like kubectl get pods, kubectl get deployments, all those crazy kube commands you have to remember, it allows you to just kind of have this visualization of logs, shells, shelling into instances, pods, viewing the YAML, listing the YAML, and much more. The way I'd like to describe it, it's basically HTOP for Kubernetes. It's pretty crazy. So it looks kind of like this. You can see things like, hey, how many pod restarts have you seen? How many do I have of this? What namespace are they in? Pretty cool. Definitely something to check out. We can view the logs from here as well. Probably not the best thing to view logs in terms of a grand scheme of things, but sometimes you just want to go in and check one pod. You're like, wait, why is this one restarting? Just gives you a quick way to log in and view it from there. Lynn, do you just want to present from my slides here and just talk about it?
Yeah, let's do that. So Helm. Helm is another tool we use, highly recommend. We use it a bit differently than most people would. So Helm is kind of thought of as like the package manager for Kubernetes. So you can say something like Helm install MySQL, and you get kind of a default MySQL setup directly in your cluster. But behind the scenes, Helm has a really, really good templating engine that's very Kubernetes and YAML focused. There's another alternative called Customize, if you're familiar. But I would definitely recommend using Helm to create templates of your deployments, because as we saw in Spinnaker, you can manually edit all of that YAML, but that's still going to become really tedious. And say you have, I don't know, 3 clusters, that's 3 pipelines, maybe dozens of apps. I mean, you won't really be able to manage that. But what Spinnaker can do is actually integrate with Helm. So you can use the really good Helm templating engine, which is really Kubernetes focused. And then you can basically render those templates using Spinnaker and pass in the outputted YAML into the cluster.
Yeah, and to add to that, you can even version your YAML too. So if you have to come back for like an audit trail as to what was applied, that's kind of something you can use too.
Yep. Okay, so another one we didn't really hit on for metrics, logs, and monitoring. You know, this is definitely a must for production. So just to share what we use, we have Grafana and Prometheus for time series metrics. We also have Stackdriver because we use GKE. We kind of do a mix of both. I would say most of what we do is in Prometheus, but sometimes it's easier just to kind of look at something in Stackdriver since a lot of it's already there since we're using Google Cloud. Jaeger we use for open tracing. We're going to talk about it on the next slide, so I'll wait on that one. And then for logging, we use Stackdriver for logs, and we also use a tool called Loki, which is basically a Grafana project tool, I guess you could call it, but it's a way to basically save and look at logs inside of Grafana side by side with your metrics, which is really helpful. And yeah, we try and stick to the open source stuff because it's free, but also because there's a really good community and lots of info available online. Okay, Jaeger, this is my favorite one. If you've never heard of Jaeger, you definitely need to check it out. So Jaeger, it's sort of more generically, it's called open tracing. I believe there's a group within the CNCF that focuses just on open tracing. So there are alternatives to Jaeger, but Jaeger is definitely the one we use and we love it. What Jaeger does is it's going to trace calls in your code as well as calls between your service, and it's going to give you a really nice graph like what you see here. So for example, if you have service A that calls service B, and service B calls service C, and service C calls Redis, and Redis goes down, how are you ever going to figure out why service A is no longer working? That's pretty tough. But with Jaeger, you can actually figure it out really easily because basically every method or function call can be sampled, including HTTP calls. So then you can use the Jaeger UI to find stuff like this and say, okay, well, someone made a post on Digital Locker, and Digital Locker then called identity, which then called product, and so on and so on. And you can actually see it down to the code level to where you can say, like, this particular method is really slow. This particular method is calling Redis. Maybe there's an issue with Redis and things like that. So when you're dealing with microservices, I think something like open tracing and Jaeger is a really good one for that. Is a must. It's definitely something you need to check out.
To further that, we touched on it that we wanted to see observability within Istio as well. And this is something that is enabled via Istio in itself, that it has all these metrics and logs already generated. Istio is fantastic. It's really powerful, but to debug an issue with sidecars outside of code, it kind of becomes like a finger pointing scenario. It's like, no, it's the proxy. No, it's the code. No, it's the proxy. No, it's the code. With something like Kiali, it allows you to visualize your metrics and your logs as to what is actually going on in your cluster. It plugs in natively with Istio. You do have to install it after the fact. It doesn't come with Istio, but it lets you create some great service graphs. So this is an example of one of our applications. You're able to see the incoming traffic flow, and you're able to see how many requests per second. What are the response codes? What's the 99th percentile, 95th percentile? How much traffic, what else am I calling? So this is, you can kind of see it calling out to Jaeger here as well too. We use Jaeger a lot. It's awesome. But this, on top of that, also gives you the ability to see proxy to proxy. So stitching this together with, with Istio, we get the observability in Kiali. With this applications, we get the observability within Jaeger. And then stitch that all together with logs and metrics, we get the Prometheus, Stackdriver, and Grafana. And it kind of gives you like a bundle of tools available to our developers to deliver and own their code. Because again, we empower them to deploy it, but at the same time, we don't just cast them into the dark of saying, good luck, I hope it works. We have to provide them a means to view and operate and own their code. And this is some of the tools that we do. So let's kind of wrap this up. We did a lot of talking, and I think there's probably a lot of questions or discussion here. So we have Kubernetes. We're highly available. We're scaled. We got Istio. We got east and west traffic done. How do we deploy? We figured that out. We're using Spinnaker. So we're done, right? Well, not really. It never ends. Sorry, that's a spoiler. Where's automated canaries? Where's the weighted routing? Where's performance tuning? But the most important thing is these are all enhancements, and these are things that allow us to focus on improving the customer experience end to end, allowing us to focus that we could get service that extra customer. We could service those 10 extra TVs, and ensuring that everyone has the best streaming experience possible. With that being said, we're going to wrap up, but we do have a tech blog. We do publish articles from time to time around this. We're looking to probably document a lot more of these things out there, share with the community. Things like FluentD, Scuttle, some open source projects that we have, any contributions that we have, or any learnings that we have in the rollout. There's definitely a lot of interesting things with large surges of traffic due to the circumstances we're in right now that I think we're collecting our data to share, and we'd love to grow and share with the community. But with that being said, thank you so much for attending today's talk. If any of this is cool to you and you think this is something you want to work on, we do have our jobs page on here. Feel free to check us out. And thank you for coming. There's a lot of things going on in the world, so we do appreciate you taking some time and joining us in kind of a discussion and presenting our architecture and stuff. So thank you, everybody.
Thanks, guys.
All right. Yeah, so this is Adam from Armory again. Don't go anywhere. We want to open it up to conversation and questions in a few minutes, but we wanted to talk a little bit more about what Armory is built on top of Spinnaker. We've seen some of the power of Spinnaker to deploy to multiple different targets that Joel talked about, AWS, Google Cloud, Kubernetes, etc. And Armory has really helped build some additional functionality on top of that to help what Joel talked about, enabling developers to deliver safely. And that's really putting those guardrails in place so that they have that path to production. And so I'm going to go ahead and actually introduce Lee Faust, who's our field CTO. He's going to give a quick demo of what we've built, and then don't go anywhere because we're going to open up to discussion, questions for anybody that has presented here. I'd also encourage people to hang out and be part of the community here. So we'll go ahead and open up and allow people to get off mute here in a few minutes. So with that, I'll go ahead and pass it over to Lee.
All right, thanks, Adam. So thank you all for having me today. And let me go ahead and share my screen real quick. Make sure I'm sharing the right one. All right. So I want to thank the folks from Redbox for coming in and talking about all the different things that they've done with Kubernetes and Istio and Envoy. It's great to be able to learn from other people who have actually weathered the storms. So we hear this a lot from our customers is, people who are deploying currently to, VMware, vCenter, vSphere, maybe they're deploying their monoliths to EC2. And this is a traditional statement that we hear from people. It's a very political battle about what applications get migrated first. Do we only choose the greenfield applications? Do we do should we be migrating applications that don't have a ton of value inside the organization just so they can meet some sort of deployment scenario? But beyond that, the key thing here is that Spinnaker can support all of the different use cases. And one of the specific use cases that we're going to talk about is this idea of being able to use Spinnaker to be able to map infrastructure together. So you heard a lot about what Envoy is doing behind the scenes and how it's mapping through its proxies and doing all this magic and all these things for you on your behalf. And for a majority of our customers, a lot of them are not at that point. It is a very complicated world when you start to move into Kubernetes, just to be able to understand how CRDs work, how the controller works, how all of the different objects work that are inside your different namespaces, how RBAC works, and how am I going to go ahead and secure this thing. And for a lot of organizations, they end up in situations where they're actually got a cross-pollination of both Kubernetes and cloud-native type applications. And they've got some legacy applications that maybe are on-prem or they're in the cloud. And one of the things that we're seeing everybody use today is some form of configuration management. So when we look at configuration management, there's, you got the top four. So you got Puppet, Chef, Ansible, and Terraform. And one of the things that we did is we had a large number of our customers that actually reached out to us because over the last probably 12 to 18 months, HashiCorp has decided to change their pricing model for Terraform Enterprise, and they made it workspace-based. And this is great for when you think about things like in the old Puppet world where we used Hyra and we promoted things from dev to QA to stage to prod, because basically you had 4 namespaces per app. And if I had 10 apps, great, I had 40 apps, and at an average of $1,000 per workspace, I'm talking about $4,000 per year per namespace. Well, unfortunately, security works a little bit differently. And as we think about security, security is done inside of the cloud providers in a way that does not allow us to be able to use that traditional namespacing type configuration. So for a lot of our customers, they're going to have things like IAM profiles, and those IAM profiles are not going to be done by app. Those IAM profiles are going to be done based on the things that you're actually going to provision. So if you're going to be provisioning ECS and Lambda and all of these other things inside your infrastructure, you end up very quickly to the point that you've got thousands of workspaces. So at $1,000 per workspace, you're very quickly getting to the point that you're spending hundreds of thousands of dollars on Terraform Enterprise. So what we've done is we've basically taken the open source Terraform capabilities, and what you're looking at here is very similar to what you saw before around being able to run things for CRDs and for Kubernetes and manifests. And one of the things that's really interesting here is we have this idea of being able to provision an S3 bucket. And one of the things that we didn't get to see is a lot of the pipelines that we saw earlier were very straight lined. And a lot of the pipelines that we see from our customers are actually very dynamic. There's a lot of pipelines depending on other pipelines, and they have some pipelines that are secured, so only operations can see their pipelines, but other pipelines are accessible to the DevOps team. So they would need a way to be able to link pipelines together. So for this particular pipeline here, what we're actually doing is we're actually going to call another pipeline that actually sits on another one, which is actually a Terraform stage. And so from this Terraform stage, we can use these things in Spinnaker called artifacts. So you can hook Terraform and Spinnaker up to your GitHub, GitLab, Bitbucket repositories. And what we can do is we can actually go in and take that information and run it through by being able to pull from that repo and actually grabbing a specific TF file and actually going in and running a Terraform. Here we've got a Terraform plan. So we're going to take our parameters, our targets, any artifacts that we want to actually use as part of this Terraform plan. And what we do is we run through this process of basic Terraform plan, apply, and destroy. Now, if we go back and we look at this particular provision S3 bucket, and we actually look at the execution, excuse me, here what we can see is we've got a successful run, but actually what we want to look at here is this particular delivery. So I'm going to go back and look at the run here. So here we can see all of the properties and parameters that are being passed in to this specific pipeline from the beginning. And then we can look at the execution details. So if I go in and look at the Terraform apply, and I go ahead and I look at the console output, this would be something that you would normally see if you were actually executing Terraform from your local machine. So now Spinnaker can actually run Terraform on your behalf. And it can actually be executed where you can actually link your deployments and your provisioning process together, allowing you to optimize your cloud utilization. So you're not creating tickets asking somebody at the beginning of a sprint, let me go off and let me go create a whole bunch of resources, and then to have that sprint never get deployed. So you've now got maybe 6 weeks or 12 weeks worth of work that has been sitting out there consuming resources that never actually get utilized by the app dev teams. So we can actually provision these things just in time. Now, the thing that's really intriguing about this is back in the first pipeline, look at the configure, is we have this notion inside Spinnaker called evaluate variables. So what we can actually do is from that Terraform script, what we've actually done is we've actually provisioned a controller. And so this is basically a load balancer. So what we do is from that particular Terraform script, we're going to look for the load balancer ingress, and we're going to go get the host name. So now if you've got, let's say, your front-end Node.js Webpack applications running in Kubernetes, but part of my back-end application is actually running on VMs or in EC2, well, I'm going to have some load balancer that's going to sit between the two of those, allowing me to be able to do things like blue greens and red blacks and canaries and all those other things that you heard about. But I'm going to need to be able to link the dynamic IP address between the two at deployment time to make sure that the front end can continue to talk to the back end when the back end gets re-provisioned and a new IP address gets created inside that new EC2 image. So this is basically an idea of how you can use the Terraform plugin that we've created on top of open source Spinnaker that you can use with your teams, where your DevOps teams and your operations teams can now use Terraform and create that single pane of glass to know what infrastructure resources are actually being used by what application resources. One of the other things that we've recently done is there is a, in 1.19 or 1.18 of Spinnaker, they rewrote what was called the Artifacts UI. So this is what the new Artifacts UI actually looks like. So what we can do is we can actually configure things with the Artifacts UI so it's not as complicated. It simplifies things a lot. So this is another example of how we're using GitHub to basically store our Terraform scripts as part of our deployment. And here we can actually go through and do the exact same type of configuration and being able to go grab information. You can see the spacing and things are a little bit different to show you where things are actually dependent on one another. So with that, I hope you've enjoyed this quick, brief introduction to our provisioning capabilities that Armory extends on top of Spinnaker. If you're interested in learning more, feel free to reach out to Adam as your host, and he'll be more than happy to go ahead and get your contact details, and we can give you a more detailed view into how this can actually work as a greater set of your application deployment pipelines. With that, I'll turn it back over to you, Adam.
All right, well, I'm actually just going to turn it over to the Meetup group here. I'm gonna go ahead and unmute everybody. So hopefully everyone behaves themselves as we are here virtually. I think there might be, I'm not sure if there's any questions. It looks like Joel and Lynn are still on, Lee's on as well. So feel free to ask questions. Feel free to say hi to some people you haven't seen in a while. So give me a second and I will unmute everybody.
I just want to say, no, Armory's been really great in the community. I know you guys sponsor a lot of hackathons and stuff in the past. So from our perspective at Redbox, even though we don't use Armory in the day-to-day, we do thank you for the contribution. Great company overall, and every time we've worked with you guys in the past has been awesome. So thank you for everything you guys do in the community. So there was a question in the chat while we were presenting around how are we handling cert rotation? Internal rotation is too frequent for an external CA. Right now, we aren't necessarily specifying an external CA within, framing this within Istio. You can specify an external CA. By default, if I'm not mistaken, the default one is a 1-year root certificate with a 90-day, 90-day rotation policy. We don't really have high requirements around this. We don't really handle anything like PCI or HIPAA or anything within the cluster. So we're kind of just writing the defaults. We were discussing maybe making it more short-lived in the near future, or maybe using our own certificate. But for now, we're just writing the 1-year root with 90-day rotation. There is, as of 1.4, there is automatic rotation APIs that you could use to rotate if you have like an external CA, so you should check that out. But yeah, right now we're just kind of running the default 1-year root 90-day rotation. It can also tie into like if I'm not mistaken, it can also tie into your cloud provider. So I think it can tie into service accounts within IAM and GCP, and I believe AWS too. So yeah, unfortunately, sorry, I don't have any cool solution around that, but definitely a lot of things are growing on that aspect though, for sure. Anyone have a question or anything you want to talk or anything?
I have a just curiosity. How's Istio 1.5 with you guys?
We have not upgraded production yet. Cluster. The tone of your voice makes me wonder if we should upgrade our production cluster right now. So far, the bump between 1.4 to 1.5 was a little bit bumpy, but I'm assuming that's because we were shifting from all those multiple binaries to like one single. But aside from that, I haven't really been looking at our siege cluster. I haven't really seen a lot of issues right now. Yet. I should probably.
Yeah, I mean, OpenShift is outright skipping 1.5.
Ooh,
Right.
ooh. Yikes! Yeah, maybe it's something we have to research more before we further progress with that, because I know that we did it in our staging environment. It was like our demo cluster, and it's been fine. But maybe some of the more complex use cases, I haven't run into anything. Is there anything specific that maybe you want to share with the community around that? Anything specific you've seen?
I mean, the differences between 1.4 and 1.5 were already over 200 PRs. There are just massive changes between 1.4 and 1.5. And unfortunately, with the APIs changing, you have to understand 1.5. You can't just go from 1.4 to 1.6 without it expecting to break.
Yeah, we got bit with that in 1.3 to 1.4 when a lot of things went from beta to V1.
Yeah.
And if you remember in our presentation, we were talking about using Istio on GKE. Well, Istio upgrades are tied to GKE upgrades. So we just roll over one day and the whole thing is just blowing up because V1 beta no longer exists and we're having to update a bunch of YAML. That's actually kind of the reason what actually spurred us into updating our templates. And ultimately, we run open source Istio. That's something I should preface. Istio on GKE is great. It's a great managed offering. It ties into a lot of things with the Anthos stuff. We don't necessarily use it to its full potential in that regard, but it's there. That was kind of the reason why we run open source as well. We wanted to have a little bit more control over that. So, but thanks for sharing. That's good to know. Maybe we need to do a little bit more testing then before we deploy everyone over. Cool. Anything else, folks? Anything we could help answer? Questions, comments? Cool. I mean, we could hang out on the call for maybe a few more minutes if someone gets inspired. I believe a lot of people are on mute, so you might have to unmute yourself if you do have questions. I don't want to stop that from anyone. I see a lot of people still muted, so if you have anything you want to chat about, but I'll probably hang out for maybe 5 or so minutes. But if not, thank you so much for coming. We'll be available Slack, Twitter, whatever, to answer, discuss in the future. So, cool. Thanks for coming, John. Thanks, Evan. Thanks, Philip, for joining. Actually, while I'm here, I might as well start sharing these slides out to the communities. So I know there was a comment around sharing slides. I will forget. So.
And Joel, I'm installing K9S right now. So.
Yes, it's pretty crazy. You know, yeah, it was one of those things where like, oh, that's kind of cool. It's like if you're actively just doing kube apply commands or kube commands in general all day, nice. It's great, and you could do like some crazy filtering and across the cluster and multiple pods, logs and stuff. It's pretty cool. Delivering Istio. How do I share that? Ah, here we go. Share. People with this link can view. Copy. Get shareable link. Okay, so I'll go to Meetup. I'm going to go here. Slides. Video coming soon. Jeff, I don't know I don't know if you're still on the call, but you guys got /DevOps on Meetup. Wow. That's not, that's crazy. You guys are like, oh, that's funny.
I thought I heard that. I thought I heard wrong when he mentioned that earlier.
No, he's meetup.com/DevOps. Like Chicago is DevOps. Like that's so cool. Funny. Okay. Well, it's 6 o'clock. We promised. Make sure you check out the K9's command reference because it can look like very simple, but it's actually very powerful when you use key bindings. Yes. Definitely. Check that out for sure. As I was saying, it's 6 o'clock. We spent 2 hours together. We into part of the day of the workday as well as personal time. We want to be mindful of everyone's time. But with that being said, thank you so much for joining us today. I'm going to probably drop off here, but if you want to get in contact, check out us on Twitter. Find us in the Spinnaker Slack. We always hang out in there all the time. Send us an email, whatever you want to get in contact with. And thank you again, Armory, again for hosting this event and allowing us to use the Zoom to share and what we do in a day-to-day. So
thank you, Joel.
Yeah, everybody.
Yep. All right. Thanks, everybody.
Later. Bye.
Good evening.
Stop recording.